So in this video, we're going to go over word problems that use logs. So this is the formula for continuous compounding interest. So A is the amount that we end with. P is our principal amount, the amount we start with. R is the rate of interest, and T is the time in years. So our first equation here, so we're going to use that formula, A equals principal times E to the R, rate of interest times time. This is an investment of $1,000 earns an annual interest rate of 7.6%. The interest is compounded continuously. This is how we knew to use this formula for 8 years. Find the final amount. So P is our principal amount. That's what we start with. Our rate of interest is going to be 0.076 because remember we're going to take 7.6 and divide it by 100. And then T is 8 years. So now we're going to put these into our formula, 1,000. And remember, this is that E that's on your calculator. And we're going to do 0.076 times 8 up here. And when we put that in our calculator, what we get is $1,836.75. And make sure you round to 2 decimal places, and if the number beyond the 5 is 5 or greater, round up. If it's 4 or below, leave it alone. Okay? So go ahead and do this one and come back to me when you're done. Again, we're going to use this. It says compounded continuously. Ooh, can't draw today, y'all. So we're going to use that same formula. A equals principal E to the RT power. And again, our principal is $2,000. Our rate of interest is going to be 0.09, and our time is going to be 12 years. So A equals 2,000, and we're going to do E to the 0.09 times 12. I'm just showing you different ways to express it. Go ahead and put that in your calculator. And again, the answer you get is $5,889.36. Being careful again at how you round. So this is the natural logarithm can be used to solve for unknown exponent in the continuously compounded formula. So here again it says compounded continuously, so we know we're going to use the formula A equals P E to the RT for so this says how long does it take. So that tells me that we don't know T. So T is what we're going to solve for an investment to double. So that means our principal doubled. So that means A is going to be equal to 2 times our principal because it says the investment doubled. And then our R is going to be equal to 0.085. Okay, so we're going to now put 2P over here, and that's equal to P to the E 0.085 T, right? So hopefully you guys can see that there's a P on either side of the equal sign, right? So we can divide that out. It's going to leave us with 2 is equal to E to the 0.085 T. Now from the last lesson, hopefully you remember that the way that we get rid of an E is to take ln of both sides. So then that leaves us with ln of 2 is equal to 0.085 of T. Now we can just divide both sides by 0.085. So you can literally in your calculator do ln of 2 and divide that by 0.085. And that's going to give us, let me see, 8.15 years is approximately what T is equal to. Okay? So the next one says the city population, which was initially 15,500, has been dropping 3% a year. Write an exponential function, and we don't have to graph it. When will the population drop below 8,000? So we're going to do our A again, and our principal amount, 1 plus, whoa, wait a minute, it says it's dropping. Do you notice that? So it's not going to be plus, it's going to be a minus our rate of interest, and then times our time. So said it was initially 15,500, so that's going to be P. It's dropping 3%, so that's rate is going to be 0.03. And then our A, which is our final amount, is going to be 8,000, okay? So that means we're going to say 8,000 is equal to 15,500. We're going to do 1 minus 0.03 to the t power. So hopefully you can see that we're going to divide both sides by 15,500 because it's being multiplied. Okay. And we could put the number there. We can just leave it this. I'm just going to put a number there for the sake of showing y'all how to do this problem. And that's going to be equal to 0.97 to the t power. Now hopefully this should bring you back to what we did, taking something from exponential to logarithmic. So this is going to be the log of 0.97 of 0.5161. That's going to be equal to t. Now we can use the change of base formula to solve this. So this is going to be the log of 0.5161 over the log of 0.97. Now what you could have put here instead of this, y'all, was this right here. You could have just put that right there, okay? So that's approximately 21.71, again, years. Okay, so now I'd like you to try this one and come back to me when you're done. And by the way, this one's a lot like number 3. Okay, so on this one again, A equals P e to the RT. So it says, how long does it take? So how long, that means that T is what we're going to find, right? So for an investment to triple, okay, so that means we're going to take our principal amount times 3. So A is going to be equal to 3P this time. And it's a compounded continuously. That's how I knew to use this formula. And then R is going to be equal to 0.072. So this time we've got 3P is equal to PE. And we've got 0.072 to the t power. So once again, we're going to divide both sides by P. That's going to give us 3 equals 0.072 to the t power to the 0.072 to the e power. T power. Now how do we get rid of an e? We do ln, right? So we're going to do ln of both sides. So that's going to leave us with ln of 3 is equal to 0.072 times t. So once again, we're going to divide both sides by 0.072. And t is going to be approximately 15.26 years. So number 6, go ahead and try this one and come back to me when you're done again. So on this one, it says Clara invests $5,000 in an account that pays 6.25% interest per year. After how many years will her investment be worth $10,000? So this one does not have continuous compounding. So this is going to be A is equal to P times 1 plus R to the t power, right? So after how many years will the investment? So that's going to be our A, because that's what our final amount is. Our P is going to be what we started with, which is the 5,000. Our rate of interest is going to be 0.0625, and we're solving for T again, okay? So this time we're going to say 10,000 equals 5,000 to the 1 plus 0.0625 of T. So once again, we're going to divide both sides by 5,000. So that gives me 2 over here. And that's equal to 1.0625 to the t power. So now we're going to put this in logarithmic form. So we're going to take our base, log of 1.0625 of 2, right? That equals t. So we're going to, again, use our change of base formula. So it's going to be the log of 2 divided by the log of 1.0625. That's going to be equal to t. So t is approximately 11.43 years. All right, our last problem In 1981 in Australia, humpback whale population was 350 and increased at a rate of 14% each year. Since then, when will the population reach 20,000? So we're going to again use this formula. Principal 1 plus the rate of interest times time. So it's asking us when would it be at 20,000. So that's going to be our final amount. Our principal starting amount would be 350, and it's 1 plus 0.14 to the t. So here again, we're going to divide by 350. And I went ahead and found a number for this. This was 57.14. And that's equal to 1.14 to the t power. Turn it to a log base 1.14 to the 57.14 equals t. So we're going to put this in change of base formula now. Log of 57.14 divided by the log of 1.14. That's going to equal about 30.88 years, and it's asking us when. So that means to get the answer, we need to do 1981 plus 30.88, and that would be 2011.88. So we'll say approximately 2012.